Hello students, today we are going to prove these three trigonometric identities. Example 1, prove that sine to the power 6a plus cos to the power 6a equals to 1 minus 3 sine square a cos square a. To prove this, we are going to start from left hand side. This is left hand side. Now, the first term sine to the power 6a is expressed as cube of sine square a. Similarly, the second term cos to the power 6a is expressed as cube of cos square a. Now, this step is in the form of a cube plus b cube. So, we can use the formula of a cube plus b cube, which is equals to a plus b, a square minus ab plus b square. Using it, we have the first bracket a plus b. Here we write in place of a sine square a and in place of b cos square a. So a plus b, we have sine square a plus cos square a. The second bracket, sine square a whole square minus sine square a cos square a plus cos square a whole square. Now moving on to another step, we have this portion sine square a plus cos square a equals to 1. So we replaced sine square a plus cos square a by 1. What we do in the second bracket is we put these two terms sine square a whole square plus cos square a whole square together, and the remaining term is minus sine square a cos square a. Student, be very careful in this step. We cannot use the formula sine square a plus cos square a equals to 1 because it is in the form of sine to the power 4a plus cos to the power 4a. We have only the formula for sine square a plus cos square a equals to 1. So we are using a square plus b square formula. We know the formula of a square plus b square is a plus b whole square minus 2ab. So for this portion, a square plus b square, we use the formula in place of a plus b whole square, we have sine square a plus cos square a whole square and minus 2 sine square a cos square a. Using this formula, a square plus b square equals to a plus b whole square minus 2ab. Now the remaining part is this one, minus sine square a cos square a is also copied. Now we can use the formula for sine square a plus cos square a, which is equals to 1. So we have here 1 square and it is like term with the last one. Sine square a cos square a. Sine square a cos square a, these two are the like terms, so they will get added. Minus 3 sine square a cos square a, which is right hand side. So it is proved. We can also use the alternative method to prove this one. So let's see. Left hand side it is here. Now the first term is expressed in the form of cube. That is cube of sine square a. And also the second term cos to the power 6a is expressed in the form of cube of cos square a. Cos square a whole cube. Now we are going to use the formula of a cube plus b cube, which is a plus b whole cube minus 3ab a plus b. Using it, in place of a plus b whole cube, we write here sine square a plus cos square a whole cube. And in the second term, minus 3ab a plus b. We have minus 3 sine square a cos square a bracket sine square a plus cos square a. After using the formula, we are working within these brackets. The first bracket, we have sine square a plus cos square a. whose value is 1 and cube is there. Now in the second term also we work inside the bracket, that is sine square a plus cos square a is 1. On simplifying, we have 1 minus 3 sine square a cos square a. This 1 will get multiplied to this 3 and we have 3 sine square a plus cos square a. So this is the right hand side. Hence, this identity is proved. Example 2. Prove that sine to the power 8a minus cos to the power 8a equals to sine square a minus cos square a, 1 minus 2 sine square a cos square a. To prove this identity, we are starting from left hand side. Sine to the power 8a minus cos to the power 8a. The first term of left hand side, that is sine to the power 8a, is expressed in the form of square of sine to the power 4a. Similarly, the second term cos to the power 8a is also expressed as square of cos to the power 4a. Now it is in the form of a square minus b square. So we are going to use the formula of a square minus b square, which is a minus b, a plus b. In place of a, we have sine to the power 4a, and in place of b, we have cos to the power 4a. So using the right part, that is a minus b, a plus b, we have sine to the power 4a minus cos to the power 4a and sine to the power 4a plus cos to the power 4a. In this line, we have used the formula a minus b and a plus b. Now, in the first part also, in the first bracket also, we are expressing each term in form of square. Sine to the power 4a is expressed as square of sine square a. Similarly, the second term of the first bracket, cos to the power 4a, is also expressed as square of cos square a. Similarly, in the second bracket, sine 4 is in the second bracket, sine to the power 4a is expressed as square of sine square a plus this cos to the power 4a is expressed as square of cos square a. Now the first bracket, again it is in the form of a square minus b square, a square minus b square. So once again we will use the formula a square minus b square. So a square minus b square is a minus b, a plus b. So the first bracket we have used the formula a minus b, a plus b. Now in the second bracket, it is in the form of a square plus b square. So for this one, we are going to use the formula of a square plus b square, which is equals to a plus b whole square minus 2ab. Using it, we have a plus b whole square, that is sine square a plus cos square a whole square minus, in place of 2ab, we have, it is 2 sine square a cos square a. In this line, we have used two formulae. The first bracket uses the formula of a square minus b square, and second bracket uses the formula of a square plus b square. After that, the first bracket, sine square a minus cos square a, copy it as it is, and inside this we have sine square a plus cos square a, whose value is 1. So we have replaced this one with its value, which is equals to 1. In the second bracket also, this portion sine square a plus cos square a has the value 1. The formula of sine square a plus cos square a is 1, and square it is here, and the remaining part of this bracket is minus sine square a, minus 2 sine square a cos square a. On simplifying, we have sine square a minus cos square a multiplied to 1 is sine square a minus cos square a, and the second bracket, it has 1 minus 2 sine square a cos square a, which is equals to right hand side. Hence, this identity is also proved. Example 3. prove that 1 plus sine alpha plus cos alpha whole square equals to 2, 1 plus sine alpha, 1 plus cos alpha. To prove this identity, we are starting from left hand side, 1 plus sine alpha plus cos alpha whole square. Inside the bracket, there are 3 terms. Now we are going to reduce it into 2 terms by adjusting the bracket here. 1 plus sine alpha can be considered as the first term and cos alpha as the second term. So it is in the form of a plus b whole square. A, it is 1 plus sine alpha and b is cos alpha. So using this formula, a plus b whole square equals to a plus b whole square equals to a square plus 2ab plus b square. We have a square is 1 plus sine alpha whole square and 2ab is 2, 1 plus sine alpha cos alpha, 2ab, and b square is cos square alpha. Now, once again, we are going to use a plus b whole square for this 1 plus sine alpha whole square. So, using it, we have a square plus 2ab plus b square, that is 1 square plus 2 into 1 into sine alpha plus sine square alpha. For this second term, we are going to open the bracket by multiplying each term of the bracket by 2 cos alpha. So multiplying 1 by this 2 cos alpha, we have 2 cos alpha. Similarly, multiplying this sine alpha by 2 cos alpha, we have 2 sine alpha cos alpha. So this bracket is eliminated by multiplying it with 2 and cos alpha. Now the last term, cos square alpha. Let's simplify it. The first term, 1 square is 1. And this one, 2 multiplied to 1 is 2 and sine alpha. So this one is 2 sine alpha. Sine square alpha copied. Then let us copy this cos square alpha here. That is, let's put sine square alpha and cos square alpha together. Now there are 2 terms remaining. Let's copy it. That is 2 cos alpha plus 2 sine alpha cos alpha. 1 plus 2 sine alpha, first and second term copied as it is, and this portion sine square alpha plus cos square alpha has its value 1. The formula of sine square alpha plus cos square alpha is 1. So we have substituted it by 1 and the remaining part copied as it is. Moving on to another step, this 1 and 1 will get added. 1 plus 1 is 2. Remaining part copied. In this step, all the 4 terms, 2 sine alpha, 2 cos alpha, 2 sine alpha cos alpha, have 2 in common. So let's take 2 common. So inside the bracket, the leftover part is 1 plus sine alpha plus cos alpha plus sine alpha cos alpha. Now inside the bracket, we are going to take again common. From the first 2 terms, we are taking 1 common, and from last 2 terms, we are taking cos alpha common. Now in this step, again, these 2 terms have 1 plus sine alpha common. That is 2 from here, from these 2 terms, 1 plus sine alpha is taken common, and leftover portion in this curly bracket is from the first part, 1 is left over, and from the second part, the cos alpha is left over. So we have the result here, 2, 1 plus sine alpha, 1 plus cos alpha, which is right hand side. Hence, the third example is also proved. Okay, students, this much for now. If you want to learn more trigonometric identities, you switch on to next video. Thank you.